All right, everyone, welcome to the very last video for the AP Calculus B practice final. This time we're going to look at questions 35 and 36 from the calculator section. And question 35 says, find the area enclosed by the two regions. I took the time earlier to graph these, and taking a look at this graph over here in the bottom, we can see that the region that we want to find the area for, I'm just going to highlight that in yellow, that's going to be this over here. So we're going to do this in two different ways. The first way is going to be probably the way that most of you are going to do this, and I'm doing the second way just to kind of do this purely academic, just in case you do need to use the second method. So let's take a look. The first thing we need to do for doing either of these methods is to find the points of intersection. So just as a quick review, to find the points of intersection, we're going to do second trace, and we're going to do the intersect button right here, number 5. The calculator is going to ask you 3 questions. First question is can you verify for me that the cursor is on the first curve that's going to intersect? And I can say yes, it's on the blue curve, and the blue curve is going to intersect with the red curve. Once you push enter, it's going to ask you the second question, which is the cursor on the second curve that's going to intersect? And yes, it is, so we'll push enter again. Now the third question, it just says guess. And it's asking you to guess, not because it's playing a game with you, but because these curves possibly intersect in multiple places. And I should say they can, and they do intersect in multiple places. So the calculator is going to find the point of intersection that is closest to your guess. So once your cursor is on top of or is reasonably close to the point of intersection, you can push enter, and it's going to give you a number. This one, I'm reading it here, is 6.623 times 10 to the negative 15. Now 10 to the negative 15 basically means 0. I'd say as long as it's 10 to the negative 5, 10 to the negative 6, 10 to the negative 7, then anything that goes more negative than that, that's going to be basically 0. The y-coordinate is 3. No debate about that. So this intersection is 0, 3. Now that we have all of that there, we're going to find our second point of intersection in exactly the same way. Second trace, number 5 for intersect. We're going to take our cursor and make sure we're on the correct curves. Yes, yes. And then now I think you can also, instead of pushing the left and right arrows, you can just take a guess by typing in the number or the x-coordinate. This looks like this x-coordinate is right around 3. So I'm just going to push 3 as my guess. Push enter, and it tells me that the intersection is at 312. So based on what I'm seeing, the x minimum is 0 and the x maximum is 3. So when we do method 1, which would be top curve minus bottom curve, we're going to use 0 and 3 as my x min and my x max. Notice that the blue curve is always on top of the red curve, and that's going to signal to me that I can use this method. So we're going to integrate. We're going to say the area is equal to the integral from x min to x max a to b top minus bottom dx. Okay, dx is important because it tells us that everything we're going to do is in terms of x. So a is the minimum value of x. We said that that was 0 right over here. B is largest value of x, and that is 3 right here. The top curve is x plus 3. So we'll replace that top curve with x plus 3. And the bottom curve is going to be the red one, which is x squared plus 3. That gives me this integral. Let's go into the calculator and do this. Now, I think, if I remember correctly, the linear curve is blue. So yeah, y1 minus y2 is what we're going to do. So let's get to the home screen. We're going to do math. We're going to do function integration, which is number 9. Alternatively, you can go alpha window and do fn int function integration. We said from 0 to 3, excuse me. We're going to do y1 minus y2 and dx, and that's going to get the job done. It's 4.5. Sweet. Now, the other option for doing this would be to do the method 2, which would be the right curve minus the left curve. Now, this method is, it's not something that you use incredibly often, but it is something which every now and then is handy to have in your arsenal. So for this one, we're going to have the area be the right curve minus the left curve. And it's going to be in terms of dy, which means that we're going to have to solve our functions so we have them in terms of y. Let's take that first function, which is y equals 3x plus 3. Let's put that over here. Y equals 3x plus 3. And if we solve that in terms of x, we get that x is 1/3 of the quantity y minus 3. If we take the other curve that we have, let's see, that other curve was y equals x squared plus 3. We would get that x is equal to, let's see, the square root of y minus 3. And I know what you're thinking. You might be thinking, well, how do I know to use the positive root and not the negative root? Well, if we take a look at where the region is and the parabola is, all these x coordinates are positive. So that means that I need the positive root over here. Okay, let's take this mold and we'll go ahead and figure this out. Now, since we're in terms of dy here, we need to figure out the maximum and minimum y coordinates. So it looks like our maximum and minimum are 3 and 12. Or minimum and maximum are 3 and 12. So let's turn that to 3 and 12. The curve on the right, that is the parabola. So we can change the curve on the right to be the square root of y minus 3. The curve on the left is a line. So the line equation is 1/3 of y minus 3. We'll do this in terms of dy. Let's grab our calculator and figure this all out now. Let's see, we're going to do the integral from 3 to 12. The first curve, that's the square root of y minus 3. I'm going to use x instead of y just because it's a convenient button to hit, and it doesn't really matter if we use y or x. Minus, and then I think it's 1/3 of y minus 3. Again, we're using x instead of y. And then dx because we're using x in terms of instead of y. And that should give me 4.5 as well. Yeah, that's a 4.5 right there. And that takes care of question 35. So let's do question 36. Find the volume when the solid generated by revolving the shaded region about, or find the volume of the solid generated by revolving the shaded region about the y-axis. So here I've gone ahead, I've taken the liberty of making that, well, that's the x-axis, excuse me. Here's our axis of rotation. And if this is our axis of rotation, we're going to go ahead and, we'll figure out our rotations. Notice that we have a vertical axis of rotation. That means we're going to be using a dy. The second thing to notice is that the axis of revolution is a boundary curve of the region. So that means we're going to be using a disk method. That should be enough for us to go on and start writing our formulas down. Let's get the general disk method formula. Actually, this is the general formula for any volume. Since we're rotating around a vertical axis, it should be AY and DY. Now that I've done that, I can use, instead of just any area formula, we're going to use the specific area formula for a disk, which is pi r squared. And the only thing we're going to need to figure out in order for us to do this is the, what's the word I'm looking for? I'm going to need to know the radius. So if I draw myself, if I start, I'm going to draw a line, I'm going to start at the axis of rotation, and I'm going to go all the way to the far end of the region. So here is the axis of rotation. We're going to draw a line perpendicular to the axis of rotation all the way to the curve. The length of this line is going to be my radius. So the radius is actually right minus left. It's going to be with the x-coordinate on the right minus the x-coordinate on the left, which means the radius is going to be equal to, see, the x-coordinate on the right is on this curve, which is this equation right here, 1/4 y squared. So it literally tells you what that x-coordinate is. It's 1/4 y squared. And then the x-coordinate on the left side, let me just highlight those. On the right side, that's on the curve. On the left side, the x-coordinate is always 0. So it's going to be minus 0 here. And that is my radius, 1/4 y squared. So let's take that formula here, copy it down, change our radius to a 1/4 y squared. And we are just about finished here because we just need the upper and lower limits. So if I take a look at the corners here, let's see if we can figure out the corners here. Down over here, we've got 0, 0. Right here. And the corner up over there, that looks like 4, 0. And I know I'm saying looks like, but I really do know that that's 4, 0, because this horizontal line is the line y equals 4. So over here, I also know that the y-coordinate is 0. No, sorry, the y-coordinate is 4 because it's on that line. And this time I'm just leaving in the question mark there for x. It's not really important what the x-coordinate is, and I'm just wasting time if I try to figure it out. What's important is that I know the y-coordinate. So now I know The lowest y coordinate, the smallest value of y here is going to be 0. The largest value of y here is going to be 4. This is ready to go in the calculator. And let's get a volume. Here's our calculator. Just like in that last problem, it doesn't really matter if I use x or if I use y. So I'm just going to use x in the calculator. And in my head, I'm going to know that that's a y. So we're going to integrate from 0 to 4. And we're going to square 1/4 x squared. 1/4 x to the second power. And then we're going to square that again. And since we're in terms of x, we're going to put an x there. Notice that these two functions that we're writing here are analogous to each other. They're basically the same thing. It's just I'm using x instead of the y. You're also going to notice that I didn't put a pi here because I'm just going to manually put a pi at the end of this, if I get a manageable number. Also, a nice touch here would probably be to ensure that my answer is going to be a fraction. So I'll put arrow to a fraction. Well, that gives me 64/5. And like I said before, I know that that's going to need a pi. So that is equal to 64 pi over 5. So that is my volume. If you are mad crazy about turning this into a decimal, you can go ahead instead of that fraction there, and then we'll put a pi here. And that should ensure that my response is going to be a decimal. Looks like we're going to have to insert. So second delete. Let's insert a pi right where the cursor is. There we go. And let's see what we get. Yeah, 40.212. Okay, that is the end of our AP Calculus review. Good luck to you all on your final. And hopefully we'll see you next semester.